Welcome to our series of videos that explore various aspects of implementing inquiry science in different science class situations. This episode looks at a science activity in a Year 5 class. The aim of using an inquiry science approach in this instance is to develop science inquiry skills in the students through acting as scientists conducting an authentic investigation. In this lesson, the students become Grime detectives in an activity derived from the TV series Mythbusters. We are going to use the inquiry-based teaching strategy described in the Science by Doing professional learning module on inquiry-based teaching, Predict, Observe, Explain, to promote inquiry learning for the students.
You guys are going to get to choose 2 places in the school you think are going to be the most grimy, and then you're going to test to figure out which one is grimier. So what do you think the word grimy means? Gross? Bacteria? I like that. Before we could make a prediction, we needed to decide what grimy actually meant. So was it dirty? Was it bacteria covered? Was it fungi covered? What does predict mean?
Hypothesize or guess what's going to happen.
Hypothesize, exactly. Guess what's going to happen? I've got predict as we're going to use what we know to make a guess. So now we know what we have decided grimy means. And grimy means it's got bacteria and it's got fungi on it. I want you to turn to the person next to you. You're going to pair and share, and you're going to think of 2 places in the school you think are absolutely disgustingly grimy. Handrail, beautiful. What else? You touch the door handles. Door handles are great. So you just need to be really specific when you're making your prediction. By using the predict, observe and explain method, I gave them space to think and decide for themselves what would be exciting to test.
I think the bottom edge of the toilet is more grimier than my rubber because no one cleaned it and even touched it.
I like that. So what we've done is we've made a prediction. But what do we have to do now?
No, we have to test.
Yes, test. We're going to perform an experiment. We're performing a test to check our prediction. What are we going to do? How are we going to do it? We are going to use something that helps to grow some bacteria. This is called an agar plate, so it's agar inside a petri dish. Around the agar plate, it's got something called parafilm, and that seals the agar plate to make sure we don't get any other bacteria growing in it that we didn't want there. We're performing an experiment. We need to do something called a fair test. Have you heard of that term before?
No.
What's a fair test, do you think? Yes?
So when you test things, you don't put way more than...
Yeah, so you make sure you're testing the same amount of something. So we're making sure that we're testing only one thing at a time.
I predict that a piece of apple from the compost bin will be mouldier and more bacterial than a sample from the screen of my iPhone.
I predict that Kim's whiteboard is grimier than Paul's keyboard.
We moved on from having our prediction and went to actually testing, got the kids out of their chairs, they put on their lab coats, they went around with all their agar plates and tested all the different places that they thought would be the grimiest in the school. For me, again, one of the most important things was that time at the end, getting them to reflect on it. What was the most exciting thing about the activity? What would they do differently? What did they find out that they didn't realise before?
The most interesting thing I did today was sticking the parafilm in the agar dish.
The most interesting thing today was working together.
Once it's been left for 4 days, we come back again, we bring out all of our plates and see what grew. Our first job is to observe our results. We are going to take our plates and we're going to just go and sit down and have a look at them. We want to have a look and figure out what's happened.
Toilet urinal.
I chose this activity because it's grimy. Kids like it. It's exciting and it's an investigation. They were being scientists for the day, or in our case a couple of days, and realising that science happens everywhere and it happens all the time. Okay, so right now we're observing and we're going to move into explaining our results. We're going to use what we know and our observations to figure out why it happened.
I was actually surprised that Sabrina's rubber was more grimier than my nose.
What explanation could you have for that?
Because more people touch the rubber than
They're putting their fingers up their nose. I particularly liked one boy's idea that he would test up his nose. because that does grow some interesting things. I thought that was, you know, he was really getting into it. He was getting into the idea of it being disgusting and grimy, and I play on that. We've looked at our observations and we've brought them back to our prediction. And then we've explained anything that we sort of was a bit strange, or even why we were right. We might have thought that the toilet seat was dirtier than our hand, and it was. So we're going to explain why that happened. So explanation is bringing our observation back to our prediction and giving it a reason. And that's what we need to see, probably, all these steps.
I really like what you've done here, where you've gone around the edges of all of these little colonies, we call them. That's nice observation. And yours is under the toilet seat. This is great because it's clean, isn't it?
Yeah.
So, and actually, this has been found when they do these tests, that underneath the toilet seat is one of the cleanest places in the house because everybody cleans it all the time. Yeah, and I think I can see lots of fungus spores here. Fungus, that sort of furry stuff around the edge. We'll look at one of these under the microscope in a minute and try and see if we can see the individual spores.
Having a guest scientist is fantastic, and I think it's good to have them there, maybe out of their comfort zone, partly because when you have a scientist in their comfort zone, their knowledge base is so much higher than the students, and it can be really, really hard for them to pull that right back down again and come at it from the kids' point of view. But the scientific process is essentially the same, and they can be as interested and excited as the students because it's new to them as well.
First, I predicted the bottom edge of the toilet is more grimier than my rubber, and then I tested with a cotton thing, and then we put it on the agar plate to make the bacteria grow. My prediction was right. The bottom edge of the toilet is more grimier than my rubber.
I predicted that the compost bin would be grimier than the heater because there was food scraps and that would grow mold. I observed that there was multicolored bacteria and different kind of mold, and it was really disgusting.
I think it actually worked really well, coming out really fresh and new and exciting and interesting and moving, and it was quite fluid. It worked well. I would, however, change the way the presentations worked. If possible, I would have them using posters. It's great, but I would have them posted up around the room. And if we were going to do a big unit of work on this sort of thing, I would actually I'd get them to do nice big posters, and I'd probably even get a science night where parents could come in and the kids could explain it to their parents and their families and get that chance to be excited about it with other people, because I think that just builds it even more.